Hello, we're going to explore the second week of Algebra 2 that focuses on SLT 4 and 5, given a function determine its inverse relation. SLT 6, graph radical functions expressed symbolically and show key features of the graph, including the quadratic. And SLT 7, that does the same thing as SLT 6, except focuses on the cubic. You can use inverse functions to find information in real-world situations. Here's a situation representing the amount of ink needed to create a sign versus the size of the sign in feet. Now consider the reverse. Let's say you knew the amount of ink you had. Could you determine the size of the sign you can make? Pause for a moment and think about what a chart would look like given the information that you have. Hopefully your chart looks something like this. Notice that the amounts on the left are essentially reversed on the amounts with the amounts on the right. Another real-world situation involving inverses is with temperature, moving from Fahrenheit to Celsius or from Celsius to Fahrenheit. On the left, we've given you the equation where you input the amount of degrees in Celsius and get the number of degrees in Fahrenheit. Now consider the steps you would use to find an inverse to see if you can create an equation where you input degrees in Fahrenheit and get the degrees in Celsius. Take a moment and think about what that equation would be. Hopefully your equation looks something like this. And if not, go back and look at your work and see if you can find the answer. These two equations are inverses of one another. So now we're going to go into Unit 1, Topic 2, looking at different equations, and we're going to start with y equals x squared. We put some points from the original function, y equals x squared, into the top. And on the bottom, we put the points on the inverse function. We know these are the points on the inverse function because the x and the y reverse between an original function and an inverse function. Now we're going to look at these graphs. The purple dots are for the ones for f of x equals x squared, and the green dots are for its inverse, which is the square root of x. Ask yourself the question, does the inverse graph represent a function, y or y not? And does it mean that every time you have a function, that its inverse will also be a function? Think about that for a moment. Also think about if these dots were to go on forever, what would be the domain and range of the original function? And what would be the domain and range of the inverse? So now we're going to consider the equation f of x equals x cubed. Again, we put in points on the original function, and we added points on the inverse function, knowing that the x and the y swap between the original and the inverse. Here we can look at the graphs of f of x equals x cubed and the inverse, which is the cube root of x. In this case, does the inverse graph represent a function? Why or why not? What would the domain and the range be of the original graph and the function? Thank you for watching this video that summarizes week 2 of Algebra 2.